Hello, my name is Corrine Wallach. I am the community manager at Neo4j. And over the last 3+ years that I've been working at Neo, I realized there's still a lot of software developers and data scientists that do not understand what a graph database is. They kind of think they know, they might have heard of it, but they really don't understand it. So I just want to take a couple minutes and explain it to you because I think it's vitally important that anyone works with any kind of capacity with data should understand what it actually is, because it really is a game changer. So I'm going to share my screen really quick. I'm going to try to make this as quick and easy as possible. All right. Sharing my screen, sharing it, working on it. I'm getting there. Hold on. Okay. All right. So I'm sharing my screen. So this is a example of like the Neo4j browser right here. So one thing that I think is really important to note, very important to understand, is that Neo4j is a database, okay? That is, it's not a visualization that sits on another database. It is an ACID compliant transactional database. So that's something that's very important. Technically, it's in the NoSQL category, but it's very, very different from most normalized relational databases in the sense that most relational databases store data in the shape of tables and joins. Neo stores the data in the shape of a graph. And when I say graph, I do not mean a chart. I mean a graph theory graph, like a network. So in the data model inside of Neo4j is like, you have your nodes here. Your nodes are your nouns. That's person, place, thing, location, right? These are your nodes here. And then, and these nodes can also have properties, which they could be like labeled right here. So those are your properties. And then you can have relationships between those nodes. And those relationships are, and in Neo4j, relationships are actually first-class citizens, meaning that they are just as important as the nodes themselves. Like, how are things connected, right? So just like you could have different types of nodes, you can also have different types of relationships. You could put properties in those relationships. You could put values so they could be weighted. You can have geospatial information. You can have date and time. So basically, whenever you have data that's complexly connected and you want to understand how these things are connected to each other, or maybe you want to find a shortest path, right? Like shortest path from here to here, or maybe you're looking for patterns in your data, or maybe you're looking for something that's like a combination of patterns, right? It might be like, if you're doing fraud detection, it might not be one transaction that sets off a flag, but it's a transaction with these other patterns that in behavior that might be kind of, raising the flag. Or if you're doing any kind of graph algorithm type of analysis, whether you're like community detection or betweenness centrality and PageRank, things like that, like network related style queries, like is the shape of your data a network or is it a table? So that's kind of like the big differences. So there's a few things that I think that are really important to note about understanding a Neo4j and what makes it different. So for one thing, Neo4j is a native graph database. And what that means is the underlying architecture of how the data is actually stored is not built on top of tables. Okay, everything is built to support this type of data model, this highly connected data model. So when you're doing a query with most like relational databases, you're indexing and then you make another hop and you're indexing there and then you're another joins, all these joins, these joins are always indexing. And that's very computationally expensive when you're doing a lot of hops. With Neo4j, when you do a query, you index to find your initial starting point. And then from there, you're just basically chasing memory pointers, which the computer happens to be pretty good at. So the benefit of that, not having to index every time you make a hop, is pretty powerful. The traversal time between doing one hop or 12 hops can be pretty consistent, which is a pretty powerful thing when you're hopping through a very, very highly connected network of things. So that's one thing that's very important to understand. And then the other thing is also the query language. So you're probably used to SQL because that's like a pretty standard, query language. The problem is that when you're working with graph databases and graph type of problems, SQL isn't going to cut it because SQL is not built for highly connected data. So Neo4j actually developed a language. It's an open language. A lot of other companies are using it. It's called Cypher. And Cypher it's basically SQL for graphs. It's more like where SQL is kind of like, give me this, like Cypher, you could be a little bit more ambiguous. It's based off of pattern matching, like more networky kind of related queries, which is really powerful. So SQL is a declarative language. And it's also based off of ASCII art, which it makes it really nice to be able to see because it looks like what it actually represents. So just a high level overview of it. Your nodes here, right, in yellow and blue, these here, they're represented by parentheses, see? And then these relationships that are directional relationships between those nodes are an arrow, literally an arrow, and then brackets with, it's almost funny to like look at it. You're like, oh yeah, that makes sense. So here's another node, right? So it's like, we're looking for a company that develops a game, but we're also looking for, there's another relationship here on this side where a company also publishes the game, where the company is Electronic Arts. Wow, right? I know, it's crazy. It's crazy. So I really like this blog post because I think it kind of shows the power of the model in general, like the data model, like being able to do a lot of these hops. But I think it also shows like the power of having a query language that can help you look into networks and graphs and patterns and pathways. It's just very cool. So I'll show you another example. This one I also think is pretty powerful. So here is an example of a video game recommendation, right? So you have, here is a video game in the yellow node, that's Fallout 3. And here, whoops, too far. Yeah, you have Borderlands 2, right? And in the blue nodes, they might be, I don't know, like consoles that the game is played on or whatever. In the green, you have different themes of the game. Is it zombie and pirates and plane and war or whatever? And remember too, like these relationships, because they're first-class citizens, you could also have values on them, so they could be weighted. You could have a lot of pirates and a little bit of zombie or whatever. So that part is also something that you could take into account, which can be pretty powerful when you're like, you know, trying to make queries based on weights. And then in red, you could have like, how is the game played? Is it played multiple player? Are you playing one player? Is it first person or with a mouse or a joystick or a keyboard? Like, how is the game actually played? Now, here if you have a user that likes both of these games here, and you want to say, okay, I want to understand who my user is, or maybe like find out what these two things have in common so I could find another game that has the most in common with these two games, right? Just generally characteristics, like what do they have in common? If you were to do this in SQL, it would be a very extensive query because of all the different types of nodes that you have and the different types of relationships. So with Cypher, it's actually very, very straightforward. You might actually laugh at how amazing it is, but so this is an example of the Cypher query for this query. No, it's crazy. It's 3 lines. So you have here is like your node in parentheses, and then here is where your relationship would be. In this case, the relationship is undefined. Any relationship, any direction. You could put a *6 in there or something if you want to look 6 hops out or whatever. There's all kinds of different things you could do with Cypher. But you're looking for characteristics and a game relationship between these two games. Bam, right? I know, it's amazing. So this is like, I think just like a really powerful example of like something you could do with not just the data model, like being able to store the data and query it very quickly, but also the ability to use Cypher to kind of help you find the things that, you know, are normally highly connected or distantly connected, or, you know, those like graphy related kind of problems. So I know you're probably already thinking about like, oh, where can I use this? Because this does sound kind of interesting. I will tell you there's a lot of really cool use cases for it. The very standard ones like recommendations, big one, fraud detection, like network and IT management. Those are like the really big ones that kind of are frequently used. A lot of like NLP related stuff, like even if you think about linguistics, like how we speak, right? That is all a graph. There's this thing that happens that we call it the graph epiphany. Basically, when you start seeing in graphs, everything, you see graphs everywhere. You can't get rid of it because everything's dependent on something else. You know, it's like all these like intertwined connections of things. But there are a lot of really, really cool use cases. Actually, probably one of my favorite things about my job is hearing about all the interesting use cases of how people use graphs. In this case, this one is het.io. If you go to het.io, they have, let me see, I'll go to like the homepage here. So like het.io. This instance was created by Daniel Himmelstein, who's a postdoc researcher at University of Pennsylvania. But you can play around with his stuff. You know, that he's got the ability for you to explore. There's like a Neo4j browser thing, and there's guides that kind of walk you through, tell you what you can do with it. We also have Neo4j Sandbox. I'd probably say that's probably one of the best places to start, just to kind of get you thinking in graphs. So if you go to neo4j.com/developer, there's an online sandbox thing here. You don't have to download anything. There's pre-existing data sets. You can just jump in. You can follow the guide, start playing around. And then once you're ready, you can kind of dig into here a little bit. There's like intro to graph databases, YouTube series, but we have all kinds of we have Graph Academy where you can go learn a self-paced tutorial and stuff. So yeah, hopefully you're going to thank me for this and not hate me for getting you addicted to graphs. I will also make sure I mention, because this does happen to people who are in the graph epiphany, they try to put graphs everywhere. They don't belong everywhere. They are everywhere. They don't belong everywhere. They are highly connected data problems. But that said, once you're addicted to graphs and you already have these amazing, awesome use cases that you want to share with the rest of the world, then you can come to me. And then, we could do something with the community. So yeah, hopefully you enjoyed this session and hopefully this was helpful. See you soon. Bye.